A senior Italian volcanologist looked at cameras this week and said, in his own words, "We are rolling the dice." That's not a headline writer's exaggeration, that's Giuseppe De Natale, a research director at Italy's National Institute of Geophysics and Volcanology, speaking in a personal capacity about what just happened beneath Naples. On July 31, 2026, a magnitude 4.7 earthquake tore through the Campi Flegrei caldera, the strongest ever measured there. Let me walk you through exactly what he said, what the science actually shows, and where the genuine uncertainty lies. The ground beneath Pozzuoli, just west of Naples, lurched. What followed wasn't calm, it was dozens of aftershocks stacking through the night. A magnitude 3.8 at 10 p.m., then a 3.1, then more. Buildings collapsed. Boulders fell onto cars and railway tracks, at least 26 people were injured, too seriously. Power went out for more than 100,000 households. Train lines were suspended mid-route. The port of Pozzuoli closed, cutting ferry connections to Procida and Ischia. More than 30 families were evacuated in the middle of the night. Campi Flegrei is a caldera roughly 13 kilometers across, formed when massive eruptions emptied its magma chamber so completely that the roof collapsed inward, leaving a vast depression now home to 24 separate craters, hot springs, and fumaroles venting sulfurous gas. The caldera was shaped by two mega-eruptions, one roughly 40,000 years ago, another roughly 15,000 years ago. Its most recent eruption, in 1538, built an entirely new hill, Monte Nuovo, in a matter of days. Before that eruption, there was a period of ground uplift and increasing seismicity lasting about a century, beginning around 1430. That historical comparison is exactly why this earthquake was reported worldwide rather than staying a local story. What scientists are watching right now is a period of uplift and increasing seismicity running since 2005 that tracks in the same general pattern as the episode that ended in 1538 with an eruption. To be direct, that comparison does not prove another eruption is coming, and no credible scientist is claiming it does. But it explains the level of attention this is getting. The process driving all of it is bradyseism, Greek for slow earthquake, describing how the entire ground surface of a caldera like this rises and falls as magmatic fluids and gases move through the underground system. The Romans noticed it centuries ago. The Temple of Serapis in Pozzuoli still shows boreholes made by marine mollusks several meters above today's waterline, physical evidence the ground once sank enough for the sea to cover those columns before rising again. The current uplift episode began around 2005 and hasn't stopped. As of 2026, the ground near Pozzuoli has risen more than 140 centimeters, over 4.5 feet. The monthly uplift rate has held around 10 millimeters. What makes this specific episode more concerning than earlier ones isn't just the total uplift. It's the trend. Crisis episodes in 1970 and 1982-84 both involved dramatic uplift and significant swarms, but both eventually subsided without eruption. In 1984, Italy evacuated the entire town of Pozzuoli, minus 40,000 people, and they didn't return for years. Since then, each successive period of activity has been stronger than the one before. The jump to this record wasn't gradual. During the week of July 13th to 19th, INGV recorded 8 earthquakes above magnitude 0, the largest just 0.8. Then July 31st arrived with a magnitude 4.7 preceded by only a small magnitude 1.7 tremor earlier that day, then a swarm of more than 30 confirmed aftershocks through the night. The epicenter sat directly in the Solfatara area at roughly 3 kilometers depth, the most active surface expression of the whole system, where the ground hisses with sulfurous gas and soil runs hot to the touch. This record displaces the previous one, a magnitude 4.6 in June 2025, which was itself called the strongest in 40 years at the time. The record has now been broken in consecutive years. That step-by-step escalation is precisely what both residents and monitoring scientists have been watching with growing concern. Now, De Natale's specific comments, delivered to the outlet fan page in a personal capacity, not as an official INGV position. He said the July 31st quake simply confirms the evolution of a volcanic process that began in 1950 with ground uplift alone and has continued since the 1970s with true seismicity. He raised a specific practical concern: major public events, concerts, sailing competitions, tourism activities continue happening in the highest risk zones of the caldera, concentrating people in exactly the places you wouldn't want them concentrated if a rapid escalation occurred. He also pointed out something genuinely uncomfortable. Many residents have no way of knowing whether their own homes could withstand the maximum earthquake. This system is expected to be capable of producing, estimated at just over magnitude 5. Earthquake engineering studies on this caldera have placed the reference maximum expected magnitude between roughly 4.4 and 5.1, based on fault mapping and stress modeling. Friday's 4.7 sits at the upper end of that range. Italian structural engineers have warned that an event in the magnitude 5 range could cause serious collapse among the most fatigued masonry and the most exposed parts of Pozzuoli, buildings not built to modern seismic codes and already weakened by years of repeated shaking. A Springer Nature Bulletin of Volcanology review published in May 2026 summarized where the scientific debate currently stands. Research proposing a critically pressurized reservoir of potentially eruptible magma around 4 kilometers deep suggested that decades more of magma injection at current rates would be needed to reach the volume behind the 1538 eruption, often cited as evidence a major eruption isn't immediately likely. What that framing doesn't rule out is a phreatic eruption, an explosion driven by superheated groundwater flashing to steam on contact with hot rock or rising gases, rather than magma breaking the surface. Phreatic eruptions can happen with little to no warning. White Island in New Zealand erupted this way in 2019, killing 22 people on the crater floor with essentially no warning at all. The 1538 Monte Nuovo eruption itself began with phreatic activity before turning magmatic. The evacuation plan for Campi Flegrei's red zone, the roughly 500,000 people considered at highest risk, assumes residents will have enough warning to leave in an organized way. Whether that assumption holds depends entirely on how the system actually behaves. A gradual escalation over weeks would provide real time. A phreatic event triggered by a sudden pressure release could provide almost none. To be clear about where things officially stand, Italy's alert level at Campi Flegrei has remained at yellow, level 2 of 4 since 2012, and it remains yellow now. Officials state that while this was the strongest earthquake in the modern record, the specific scientific indicators that would trigger an escalation sustained acceleration in deformation. A dramatic jump in gas emissions or magmatic signals in seismic waveforms haven't yet been crossed. That's a measured, data-driven position. It's also the position critics like De Natale argue may be too conservative, given how quickly a phreatic scenario could unfold. None of this is a prediction that an eruption is imminent. De Natale himself didn't say that. He said the probability isn't negligible, and that preparation is running behind where it needs to be. Both things can be true at once. This remains, by every serious scientific account, a low probability, high consequence risk rather than a looming certainty, and it's also a system that has broken its own record several times in 3 years on rock measurably weaker than it was decades ago, sitting directly beneath millions of people. Another reason Campi Flegrei attracts so much scientific attention is because researchers believe the caldera has entered what they describe as a progressive weakening phase. Over decades of repeated uplift and subsidence, the rocks above the hydrothermal system don't simply return to their original condition after every crisis. Laboratory studies suggest that repeated cycles of stress gradually reduce their strength, making it easier for new fractures to form during later episodes of unrest. That idea helps explain why recent earthquake swarms have been producing larger magnitudes than similar levels of uplift might have generated several decades ago. Imagine repeatedly bending a paperclip. The first few bends require noticeable force. But each time you flex it, the metal weakens slightly until eventually even a small movement is enough to snap it. Scientists caution that volcanic rock isn't identical to metal, but the principle of accumulated damage is similar. A crust that has fractured thousands of times over many years may eventually respond differently to the same amount of pressure. Several recent scientific papers have argued that this gradual weakening could explain why Campi Flegrei has become progressively more seismically active, despite uplift rates remaining relatively stable. The pressure being added underground may not be increasing dramatically. Instead, the surrounding rock may simply be less capable of containing that pressure than it was during previous decades. That possibility has become an active area of research because it directly affects hazard assessment. If the crust continues weakening, future earthquake swarms could potentially generate stronger shaking even without major changes occurring deeper within the magmatic system. That distinction matters because stronger earthquakes increase risks for buildings and infrastructure, regardless of whether an eruption ever follows. This is also why Italian authorities continue inspecting buildings after significant earthquakes instead of assuming everything remains safe simply because no eruption occurred. Repeated shaking produces cumulative effects. Small cracks can widen. Masonry weakened by one event may become more vulnerable during the next. Historic structures, many built centuries before modern seismic standards existed, are particularly susceptible to this gradual deterioration. The city of Pozzuoli contains numerous historic buildings alongside modern construction. Some have already undergone strengthening projects following earlier bradisseismic crises, while others continue requiring regular assessment. Engineers aren't only concerned about one exceptionally large earthquake. They're equally concerned about the accumulated impact of hundreds or thousands of smaller ones occurring over many years. Another frequently misunderstood point involves the relationship between earthquakes and eruptions. Many people naturally assume that stronger earthquakes mean magma must be moving upward. In reality, volcanic systems can produce significant earthquakes entirely through the movement of hot fluids and changes in underground pressure. Separating those two possibilities is one of the central challenges facing volcanologists. That's where gas chemistry becomes especially valuable. The composition of gases escaping from fumaroles can provide important clues about conditions at depth. Carbon dioxide, sulfur dioxide, hydrogen sulfide, water vapor, and several other gases are monitored continuously. Changes in their relative proportions sometimes indicate new magma releasing fresh volcanic gases into the hydrothermal system. At present, scientists report that while gas emissions remain elevated compared with earlier decades, they haven't shown the dramatic changes expected if large volumes of fresh magma were rapidly approaching the surface. Satellite observations provide another independent line of evidence. Modern radar satellites can detect changes in ground elevation measured in millimeters across enormous areas. Those measurements confirm the continuing uplift centered around Pozzuoli while allowing researchers to map exactly how deformation spreads across the caldera. Combining satellite data with GPS observations creates one of the most detailed deformation records ever assembled for any volcano. This combination of monitoring methods explains why scientists are generally confident about describing what the caldera is doing today, even while remaining uncertain about exactly what it will do tomorrow. They know the ground is rising. They know earthquakes are becoming stronger. They know the hydrothermal system remains highly pressurized. Those observations are supported by multiple independent instruments. The uncertainty begins when researchers try projecting those trends into the future. Volcanic systems rarely follow simple, predictable paths. Some remain restless for decades before gradually calming down. Others transition from prolonged unrest into eruption over periods ranging from months to years. There isn't a universal timetable every volcano follows. Campi Flegrei's own history illustrates that uncertainty remarkably well. The caldera has experienced repeated episodes of uplift and seismic unrest over centuries without every episode ending in eruption. That historical record reminds scientists to avoid assuming that today's activity automatically points toward tomorrow's outcome. At the same time, history also demonstrates that Campi Flegrei is fully capable of erupting. The Monte Nuovo eruption of 1538 remains clear evidence that this volcanic system can eventually transition from unrest into volcanic activity under the right conditions. That dual reality is exactly why monitoring continues around the clock. Perhaps the greatest challenge facing civil protection officials isn't the science itself but communicating uncertainty to the public. Saying an eruption is impossible would be inaccurate. Saying one is imminent would also be inaccurate based on current evidence. The responsible position lies between those extremes. Acknowledge that the system is experiencing genuine unrest. Explain what scientists are measuring. Identify the specific indicators that would suggest increasing risk, and continue updating those assessments as new observations become available. For residents living inside the caldera, that uncertainty can be emotionally exhausting. Months or years of recurring earthquakes affect daily life even when no eruption occurs. People worry about their homes, schools, businesses, and families. Sleep becomes difficult during intense earthquake swarms. Even relatively minor tremors can create understandable anxiety after years of ongoing activity. That's why scientists increasingly work alongside psychologists, emergency managers, and local governments to improve risk communication. Helping communities understand uncertainty is now considered almost as important as monitoring the volcano itself. Clear information reduces confusion, discourages misinformation, and helps residents make practical decisions based on evidence rather than rumors circulating online. So where does that leave Campi Flegrei after this record-breaking earthquake? It remains one of the world's most closely monitored volcanic systems, showing unmistakable signs of ongoing unrest while still remaining below the official thresholds indicating an imminent eruption. The strongest earthquake ever recorded inside the modern monitoring era is unquestionably significant. It deserves careful scientific attention and continued observation. But the broader story isn't defined by one number alone. It's defined by years of steadily accumulating evidence, ongoing debate among experienced volcanologists, and an extraordinary effort to understand one of Earth's most complex volcanic systems before it decides what comes next. One final point deserves attention because it often gets overlooked in discussions like this. Volcanic crises are rarely defined by a single dramatic moment. More often, they're long scientific investigations unfolding in real time, with researchers constantly testing new observations against decades of previous data. Every earthquake, every millimeter of uplift, every change in gas chemistry either strengthens or weakens competing explanations for what's happening beneath the caldera. That's why scientists continue updating their assessments instead of treating any single event as a definitive answer. For now, Campi Flegrei remains in a state of elevated but closely monitored unrest. The strongest earthquake on record has undoubtedly increased concern, but it hasn't erased the importance of every other monitoring signal that remains below critical thresholds. If those signals begin changing together in the weeks or months ahead, the scientific picture could shift quickly. Until then, the most responsible approach is the one volcanologists themselves are taking. Watch the data carefully, prepare for every plausible scenario, communicate openly with the public, and avoid drawing conclusions that the evidence doesn't yet support. If you want to follow this as it develops with real, sourced updates rather than exaggerated claims, subscribe and turn on notifications. I'll keep bringing you the actual monitoring data as INGV publishes it.